Okay, 5, 4, 3, 2, 1, here we go. Today, laws of logarithms. We're going to do some things today that look like magic to you, but they're not just magic. For example, if you remember from yesterday, suppose we had the log base 2 of 2 to the 9th power. Do you remember what you can just do? Yeah, that those just are gone and you're left with 9. Yeah, they were inverse operations. And so then you remember if we had, say, like 2 to the log base 2 of 50, that, again, the 2 and the log base 2 just cancel, leaving you with 50, right? That was a beautiful thing. Today, you're going to learn how to deal with products and quotients and constants in this situation. So just to try to make my point here, if you had x to the 5th times x to the 9th, what does that give you? X to the 14th. So what you did is you said that's x to the, so notice instead of 2 bases, you have 1 base, and you did a 5 plus 9. Agreed? Okay? So today's expression of logarithms is kind of like what we do with exponents. When you're multiplying, you add. Are you okay with that? When you multiply, you add. And so it works with logarithms. When you have a single logarithm of a base of these two things that are being multiplied together, you can separate into 2 and add them. Log base A of A plus log base A of B. So you can take the logarithm of a product and write it into 2 logarithms. Who can anticipate what we will do if you're dividing? Yes, you'll subtract. Very good. Log base A of A minus log base A of B. And for this final one here, if you notice, if you have, say, x to the 2nd, and you're going to then take it to the 30th power, what do you do to those exponents? You multiply them. So in this case, if you have something to a power, you can actually multiply it out front. So it's that power c times the log base a of a. A constant, whatever the exponent was, drops out front. Okay? All right, so let's use this for an example. Do a couple basic problems and a couple that are more challenging. It says use the laws of logarithms to rewrite these expressions. We don't want a product. We do not want a quotient. We do not want a root. We do not want a power. So right now you have a product. Here you have a product and a power. Here you have a quotient and a power. We don't want those existing. So I can simply take this and rewrite it as log of 5. Anybody know what I do after that? Plus the log of 3. That's it. In this situation, I can write log of 3. Anybody know what I do next? Good. I'll write it as plus log of 4 squared first, and then plus log of 5 to the 6th. Now that we have those, as Sophie was talking about, you can take this 2 now and move it out front. And the 6 and move it out front. So it becomes log of 3 plus 2 log of 4 plus 6 log of 5. Try the next one on your own. Go. Okay, let's see what you got. In this situation, I'm going to bring the 3 out first. Sometimes people are wondering, do I divide it up into subtraction first, or do I bring the 3 out first? And this is the answer. Pay close attention to this. If you were to perform the order of operations, you would first start by taking 4 divided by 7, right? And then after that, you would cube it. So you perform it in the reverse order of operations. So because cubing is the last thing you did, it's the first thing you move up front. So 3 times the log of 4 over 7. See how the 4 and the 7 are being taken to the third power? So the 3 needs to attach to both. So 3 log of 4 minus 3 log of 7. Or you could write it as 3 times the log of 4 minus the log of 7. Whether you have it in parentheses out the front, either way is fine. Okay, the next one. What would you do here? How would you start? Good. 1/2, I heard. We're going to take log base 3 of x squared minus 5, and we're going to raise that to the 1/2 power. Now that you recognize that, what are you going to do? Yep, take that 1/2 and dump it out front. So it becomes 1/2 log base 3 of x squared minus 5. Now at this point, some people will want to take that 2 and move it out front. But just remember here, order of operations says we take something and we square it, and then we subtract the 5. Is there any rule up there that says you can undo subtraction? No, it says you can undo multiplication or division, but you can't undo subtraction. So you're done. That's it. That's all you can do. Can't do any more of that. Try letter E on your own. We aren't going to do letter F. Try letter E on your own. If you can get letter E, you are golden. You're ready. Okay, so did you start by doing that? That's how you have to start. Now, people sometimes want to move the 4 out front. Well, is 2 being taken to the 4th power? No, so you can't move the 4 out yet. Think about your order of operation. If you plug something in for x, you would first take it to the 4th, right? And then you would multiply it by 2. So since multiplying by 2 is the last thing you do, it's the first thing you need to undo. Natural log of 2 plus the natural log of 4, x to the 4th. Minus the natural log of x minus 2 to the 3rd. Now you can move the exponents out front. The natural log of 2 plus 4 natural log of x minus 3 natural log of x minus 2. Now, something that's important for you to notice that will help you kind of check your work as you're working on the tests and things of that nature. Notice how 2x to the 4th is in the numerator and x minus 2 to the 3rd is in the denominator. Stuff that was in the denominator ends up being negative because in the denominator you have a negative exponent. Whereas the stuff that's positive is in the numerator because that's where you have positive exponents. Does that make sense? Okay, if it's positive, if it's in the numerator, it should be positive. Denominator should be negative. Flip it over. Now the directions are opposite. Instead of separating into multiple logarithms, let's write as a single logarithm. So we want this to just be the log base 2 of something. Anybody know what it would be? There we go. 5 times 7, which is 35. Pretty straightforward. What about this one right here? I'm going to rewrite this as 2 times the log base 5 of 3 minus, and then dividing by 3 is the same as multiplying by what? 1/3. So this will be minus 1/3 log base 5 of 64. Okay, so if we rewrite it like that, what do you want to do first? That's something we could do. Yeah, we could deal with those exponents. So we could take the 2 and move it on up. We can take the 1/3 and move it on up. So I will rewrite this as log base 5 of 3 squared minus log base 5 of 64 to the 1/3 power. Let's actually evaluate it now. So 3 squared is 9. So I have log base 5 of 9 minus, and then 64 to the 1/3 power. That means the cubed root of 64. What is the cubed root of 64? It is 4. Very good. So minus log base 5 of 4. So I still have 2 logarithms. I need 1. So it's going to be log base 5 of 9/4. Good. Okay. You've seen a nice example. Try letter C on your own. So you can get C. Okay. Let's see where you're at. Okay. So, and again, sometimes the reason why I let you go through it on your own, studies show that you remember much more if you try something and then see your mistake, as opposed to me just doing it correctly on the board all the time, right? It's always easier when the teacher does it, right? So let's see what happens here. So the first thing is I'm going to move the 2 up, I'm going to move the 3 up, and I'm going to move the 1/2 up. And I get the natural log of 4 squared, which is 16, minus the natural log of 2 to the 3rd, which is 8, plus the natural log of 2 to the 1/2, which is the square root of 2. Okay? Everybody okay with that? Now, there's 2 things that people missed here as I was going around looking at people's work. The first thing is sometimes people tend to write it with multiple logarithms. For example, sometimes people like to write, say, the natural log of 16 over the natural log of 8. When you do that operation, it becomes 1 logarithm. It's 1 logarithm. So if you say the natural log of 16 over 8. But before we talk about that, I also want you to look at it, and I told you guys, if it's positive, it ends up in the numerator. If it's negative, it ends up in the denominator. So if you're not convinced by that, watch how I can simply rewrite this. Is this not the same as what I have up above? Natural log of 16 plus the natural log of the root of 2 minus the natural log of 8. Those are the same things, right? So you can see it's the natural log of 16 roots of 2 over 8. So these get multiplied, that one gets divided by. These are positive, they're in the numerator. This is negative, it's in the denominator. See the difference? And so 16 over 8 is the natural log of 2 roots of 2. You should, yep. Letter D. If you were to just start that, what would you start by doing? Looks complicated, it's really not that bad. Just think of something to do. What would you want to do? Okay. Yeah, so I hear multiple thoughts. You got lots of options. I like the idea of distributing the 3. So I'm going to multiply the 3 there, the 3 there, and the 3 there. You guys good with that? So I got 3 natural log of x plus 1 plus 3 natural log of x plus 2 minus 6 natural log of y. Now that I see those constants out front, what can I do with those constants? Yeah, move them up to become exponents. And I get the natural log of x plus 1 cubed plus the natural log of x plus 2 cubed minus the natural log of y to the 6th. Now this is very, very, very familiar to the last one we did, similar to that. Okay? What ends up in the numerator? Yeah, the x plus 1, the x plus 2 is what's in the denominator. Y to the 6th. Okay, they're positive, they're being added, they're in the top. This is being subtracted to the bottom. So the natural log of x plus 1 cubed, x plus 2 cubed, y to the 6th. That's that. There really is basically no practical application for this. But the course is pre-calculus, so what do you think it prepares you for? Yeah, I mean, these things, they make my calculus life a lot easier. Like, if we don't have these, some of the calculus problems, they become ridiculously challenging. Like, challenging or so. I'm like, I don't know if I can do that. So this makes life a lot easier. You'll like it when you're using calculus, trust me. All right, we flip over to this, okay? These are good problems. People like these. You're going to like these. This is actually easier than what we looked at. So to evaluate the following expressions, I have the log base 2 of the root of 32. We kind of did some of this the other day, but now we're going to use some of the properties we just did. I'll give you a hint how to start here. Log log base 2 of 32 to the 1/2. So I want to come up with an actual value. I want to evaluate this. Anybody want to guess a step I could take here to evaluate this? Sure, yeah. I heard people say move and multiply, so I can move that 1/2 out front. So 1/2 log base 2 of 32. Now there's one thing you have to see this. You got to be able to see this. Anybody see it? 32 is the same as 2 to the 5th. See, people see 32 as 2 to the 5th. So I could rewrite this as 1/2 log base 2 of 2 to the 5th. And I heard my good friend Lily say, cancel it out. Log base 2 and 2, those will cancel. Leaving you with 1/2 is not 1/2 to the 5th, it's 1/2 times 5. Which is 5 halves or 2.5. Yeah. Try letter B on your own. Let's say about 2/3 of people got first hour. You guys can beat that. Let's go for 75%. Hey, do you have blonde hair? You have blonde hair? Yeah. No. Definitely not blonde. Nope. But it is in the sun right now. It's kind of glistening. How long do you let your hair grow? What's the longest it's been? Is that the longest it's been? Okay. You didn't ask me how long I've been growing this out. 2 days. Okay, what did you do first? What did you do first? Log base 5 of what? Oh, you went that route. I started with 100 divided by 4. Is it okay with that? Oh, now you see it. What's 100 divided by 4? Yeah, I combined them. I made 1. I just made up the 2/3. I don't really know. I was just trying to inspire you. And then log base 5 of 5 squared. Yep, I cancel that out. We're going to get 2. How about letter C? How about you think we can do C? Try C. I'll do D for you. D's a little bit more complicated, but I bet you can do C. Try C. You guys are smart. Yep. Oh, wow, we got high fives and smiles going on. Maybe 20 more seconds. Come on, son, we'll go over it. You guys are so good at this that you can watch Mexico get a bunch of yellow cards and lose the World Cup as opposed to watching your math lessons still do well. Very proud of you. I'm going to give you a yellow card, buddy. All right, what'd you do first? Yeah, 4 times the log base 3 of 27. 27 is, man, you guys are smart. Log base 3 of 3 cubed. What happens there? Boom. 4 times 3 is, man, you guys are good. Way to go. Bye. Yeah. All right, just a couple left here. We got e to the 3 natural log of 5. Oh, boy. That looks complicated. Hey, good luck, y'all. Have fun. Don't e and natural log cancel each other out? What's in the way? 3. How can we get rid of the 3? Put top right, I like the way you think, e to the natural log of 5 cubed. So 3 can move up on the 5, can't move out in front of the e. Very good. So now these cancel right here. E to natural log, we get 5 cubed, which is 125. Sure. Yep. Okay. Everybody for this last piece got to take out your calculator. Calculator needs to be out. Well, good news or bad news? Bad news is, if you can't do what we do right now, okay, if you can't learn this piece, then you've got no shot on Monday. Like, Monday's just done. Like, you will not be able to do Monday. Okay? You want the good news? It's really easy. No, it's a new lesson on Monday. But what we're doing is easy, but it's new. But if you don't know how to do it, if you don't figure this out, you will not be able to do Monday. Lost cause altogether. Gone. So, let's check it out, okay? This says log base 6 of 14. Now, we were able to figure out the other ones, but this one, 14, it's really kind of tough to write that with a base of 6, right? Like if it was 36, we'd be happy, right? But it's not 36, it's 14. What this means is 6 to what power is 14? Oh, boy. Well, what's 6 to the 0? 1. What's 6 to the 1? 6. What's 6 to the 2? Somewhere between 1 and 2. I want you, for a minute, 20 seconds, to guess and check and see how close you come up with the actual answer. Guess and check. Plug it in calculator. See what you know. It's somewhere between 1 and 2. Go. See how close you can get. Closer. I want you to get like 14.00000. It's between 1 and 2. Yeah, you're aiming for the wrong number. Got 20 seconds. Okay. Oh, man. Ooh. All right, stop. Who thinks they got a really good value for x? Allie? 1 point. Okay, so what was your x value then? 1.474. Let's try. So 6 raised to the 1.474, and I get, okay, so I'm definitely going to have to reduce it. So 6 raised to the 1.473. Oh, that's even better, isn't it? I'm going to go 6 raised to the 1.4. I'm going to try 28. Whoa, that was too much. 6 raised to the 1.4729. Ooh, that's not bad, is it? I could do like 0.285 or something like that. You guys kind of get the idea, right? What if we had to do this guess and check for every problem? Wouldn't that be just, yeah, right? Hopefully there's a better way. Is there a better way? I'll show you the better way. You ready for the better way? Okay, here we go. We got to get rid of this whole base 6 thing. And so here's what we can do. It's super simple. Log of 14 over log of 6. That will give us x. So if you simply change the base, notice how the base used to be 6. What I wrote now, what's the base now? 10. So as long as you change it to the same base, so base 10, or say you use like natural log of 14 over natural log of 6, either one is fine. These will give you the exact answer. So we know it should be about 1.4729, so we're right about that. Let's try, and make sure you plug it into your calculator correctly. So try it right now, because I can't stand when you do this wrong on the test. Log of 14, what do I have to do now? Close it with a parenthesis. Thank you. Then divide by log of 6. Close again, and I get 1.4288594. Now, your book says to write it out to 6 decimal places. Can we agree that seems a little extensive? Can we agree on 3? So we'll go to 3. 1.472. And I don't care if you round it up to 3 or if you leave it as 2. Just give me the 3 decimal places. Good with that? All right, so what does this mean? Okay, this means 7 to the x power is 2. Well, what's 7 to the 1 power? Yeah, 7 to the first power is some number between 6 and 8. 7, yep, yep. So would everybody agree that this number has to be less than 1? Yeah, so let's see what it is. You do log of what? 2 divided by the log of 7. .356. And if you ever want to check it, just type it in. 7 raised to the 0.356, and you get, right about 2. Try letter C on your own. Go. All right, somebody give me 3 decimal places. What do you got? 2.807. All right, I'm going to check 14 to the 2.807, and you get, notice how it's off by a little bit, isn't it? That's because we didn't go to the full 6 decimal points. So that's why they want you to go to 6, so that if you check it, it's more accurate. That's just the way the exponentials work. But I know that I think 3 decimal points is enough, if you guys are okay with that. Okay, good job. So why do you think I gave you a work day tomorrow? Because generally people have questions on this type of homework. You guys have done a great job this year. I feel bad. You guys are a group that, you kind of lost some mathematics due to COVID, but you're back into the swing of things. Like, we're not really slowing down much at all this year. We're probably about, I don't know, maybe 5 days behind where we were, say, 4 years ago. You know what I mean? Like, so if I look at what I was doing 4 years ago, probably 5 days behind. But that's not too bad. Last year we were like 15 days behind. It's like, what did you guys do last year? You know what I mean? But you guys are figuring it out. Good job. So tomorrow we get some time to work and ask questions. And then Monday and Tuesday we have a lesson. And then after that, let's get ready for your test.